Hi guys, in today's video we're going to look at standard electrode potentials, electricity, the use of half cells, or hydrogen half cells, metal ions with metal ions, measuring standard electrode potentials, the electrochemical series, and finally an exam style question.
So what is the standard electrode potential? Well, it's represented by this symbol here, and it's an incredibly important definition you need to know. The standard electrode potential is the electromotive force, or EMF, of a half cell compared with a standard hydrogen half cell. And it's measured under standard conditions. These standard conditions are 298 degrees Kelvin. It's measured in a 1 mole per decimeter cubed concentration of ions and at 100 kilopascals. So what exactly are these half cells we referenced in our definition? Well, a half cell is a half equation. Now, often, practically, what we have is we have a metal. So, for example, if we were looking at the half equation involving copper, we'd have a copper rod, and we'd have our metal submerged in an aqueous solution of ions. In the case of copper, that'd be copper 2 plus solution, those Cu2 plus ions. And you can see the half equations that I was talking about right here. For copper, we have our copper metal here, and on the left-hand side, we have our copper ions and those electrons that have been lost. Now, it's convention to represent the electrons on the left-hand side, so it's important that they are always on the left-hand side. Now, you can see there's this dynamic equilibrium established, and we're going to have a look at how this is established, what it means, and how we measure the potential difference. So I'm going to focus by looking at the magnesium half cell. So you can see we have our magnesium metal rod placed in, this time we have water. So the magnesium metal atoms have a tendency to shed electrons to form ions. Now these electrons are left behind in the metal and they build up, and you can see them represented as these red negative charges here. Now the ions which are formed tend to stay on the surface. They're positive and they're attracted to the negative charge of our magnesium metal. Some will rejoin the metal. You can see that over here where it says an ion has picked up 2 electrons and rejoined the surface of the metal.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.